Hey everybody, Lars here. Time for number two review video for Unit 3, the infamous Unit 3. Last time we went over functions. This time we're going to go over the second part of basically our big unit on modularity, and this one's about file I/O. And before we get going, when I say I/O, I mean input and output. Before we get going on it, I was just going to tell you a little story. Back in the dinosaur days when I went to school for computer science, back in the 80s, we didn't really have a handle on how to teach computer science the way we do now. Back in those days, you went to school and you basically got an intro course where they taught you how to program with a language called Pascal. And then you took data structures, and you're going to see a little data structures in our last unit. And after that, it was the wild, wild west. There was operating systems, compilers, cryptography, no real sequences for discrete mathematics. They just threw us off to the math department and told us to take probability and stats. It was all over the dish. One thing that they really like to do is they like to have a bazillion classes, each for a different programming language. So when I went to school, I took a class for COBOL. I took a class for PL1. Which was RC back in the olden days. It was used for creating operating systems for big old mainframes, PL1. There was Pascal, there was Fortran. We never took BASIC. I came to school knowing BASIC. A whole bunch of different programming languages. C was popular at the time. And what would happen is if you took all these language classes, after a while, you would notice that all of the topics would repeat themselves. You started out with data, then you would start out with arrays and how to group your data and do things like that. Then you would start out with iteration and loops, and then you would go on to functions, but at that time we called them procedures, and you would have procedures that sometimes passed by parameter and sometimes passed by value. And then you would have functions, and then you would have some other things. But one thing that was always conspicuously absent was file I/O. And I always thought that was strange, because once you become a professional programmer, once you start programming in a professional capacity, it's all about file I/O. No one is ever going to approach you and say, create a list of the first 500 natural numbers and find the sum. Believe me. You are going to be given a file with data, and you're going to have to examine that data and figure out what's going on. So I always thought it was important to do file I/O. Oh, you're going to have to forgive me for schwitzing like I am. I just got done swimming at the pool over at the Y, and now I'm sitting in my dining room, and it's like a hot box in here. I digress. So even back then in the olden days, I promised myself if I ever taught computer science or ever taught programming, I would not skip file I/O, because I think it's important to see it, to get a handle on what it's about, and to do things, reading and writing files. So this one little section in the middle of Unit 3 is me giving it back to the people who taught me in the 80s for missing file I/O and making me do it myself. Shame on them. There should have been something about file I/O in class. You are not going to be as unfortunate as I was. I will go over it for you. So that is my little story when it comes to this. I want you to see file I/O because I think it's part of modularity, keeping your data off to the side and separate, and then using it. Because as you've seen so far, what we've been doing is we've been pretty much maintaining and using our data inside the program. Once you stop running it and shut down your computer for the day, that's it. It's gone. Goodbye. So basically what keeping files is just durable data. It's durable storage that when you save it to that file and you shut down your computer and you come back the next day, that data is still going to be there because you saved it to a file. You've saved it to a durable store that's always there for you to read your stuff from. And it's an important concept, and it's an important thing to wrap your head around. So hopefully this won't be super long. I know I always say that. I know I always go super long. But let's see what we got. I set up some code for us to use. So I think I zotzed out the rest, so I should be good. As you can see, I do my comments. And then I set up a very simple read. I created a file called small e22. You'll notice in your slides we talk about the e22. I think that's because it was used for Euler problem number 22, and it's a list of like 5,100 something names. Well, I made a smaller one. and I'll open it. What do I want to do? I want to open it with Notepad. And as you can see, it's got less names, 500 something names. We're going to find out in a second because we're going to get a grip on this guy, and we're going to figure out exactly how many things are in there. But that's all it is. It's just a text document file sitting on my hard drive in a directory called Python Data Science Summer 2016 Unit 3. So that's where this particular program resides. As you can see, if you're going to open up a file, you want it to be in the same directory as your program, or you give it the full directory path. And down here, I just create a string called infile, and I give that string the name of the file. Then I come down here, and I do the first of our 3 file operations. And what they are, just from the slides, it's real easy. What I want to do first is I want to open the file. Then the next thing I want to do is read from the file. Then the last thing I want to do is close the file and tell Python, hey, I'm not using it anymore. Free up the resource, give it back to the operating system, everything is good. So basically, that's what these 3 lines are. I create a variable called f, and I assign the result of the open function. You know what a function is now. And that takes as arguments a string, which is the file name, and a string, which is a single character telling me what I'm going to do with that file. And as you're going to see later, I can also use a W for writing, but right now I'm going to put an R there because I want to read from this file. Okay? Then, in the second line, I read. I create a variable called data. I assign to it the value of f, my variable, dot, and that means we're running a method on our variable, read. So when I create this f up here, I'm saying, hey, this is a file. Open it up and set it at the very beginning of small e22.txt. Okay? Now, this line right here says, read all that data and put it in the string data. Okay? Then, because I'm a good citizen, a good file reading citizen, I'm going to close my file and return the resource back to the operating system or back to wherever I'm running the program. And that's it. I'm done, but I've gotten the data I need, and it's now in a variable in my program where I can use it and do things with it. What I do here is I just print it. So why don't we go ahead and run this? I'm just going to do Control-S, F5. And look at that. There it goes. It runs. So I've taken the contents of small e22.txt, and I put it all in a pretty big string called data. And as you can see, it's right there. And I dumped everything out. And actually, let's see how long that is. I will print a len on it. All right, 5,128. Now remember, that's characters, because I'm counting how many characters are in the string. So that's not names, okay? Even though that number is kind of close, isn't it? 5,130 something was how many names. That's how many characters are in that string, okay? So now I've got a string with my data in it, but there's not a whole lot I can do with it right now because it's a string, and I can count how many characters are in it. But as far as the individual names, it's kind of caught in the middle. I mean, I can slice into it. I can say, give me number 4, and it'll say Y. And if I go to the top here, and I see Mary is 0, the quote, 1, 2, 3, 4, indeed. Y is the 4th character. But, you know, I'm not going to want to sit and go through that entire list and slice everything. I'd rather get the names into a data structure where I have each name as an individual unit. And so what is that? We already did it in Unit 2. That's a list. So how can I take this string and make it into a list? First thing I'm going to do, and I already have this coded up, so I'm going to bring that little piece of code up here. Ta-da! And let me do 1, 2, 3, do that. So the first thing I'm going to do is I'm going to comment that out because I'm going to run it with just the replace. First thing I want to do now is clean my data. So I have my string data. I'm going to make it equal to data replace, and I'm going to replace every double quote with nothing. See, that is right in a row. Single, single. So I'm using single quotes as my delimiters here, and I'm replacing all my quotes with nothing. And then I'm going to print it. Let's see what we get now. All right, you see where I run it? I now have no more double quotes in there. I just have names, and they're separated by commas. Okay? So that's a good thing, but I'm still a string. Okay? I am still, and we're going to take a look. I'm not just going to tell you. I'm going to prove it. I'm going to show it to you. We are still class string. We are still a string. So what I want to do now is I want to run what's called a split. Split does two things. The first thing split does is you give it a delimiter, okay? In this case, a comma, all right? So when we run this, it's going to look for the comma and split out everything by the comma it sees and put it in a list called data. So split does two things. It delimits by whatever you give it, and you'll see later we can use tabs, we can use spaces, we can use whatever we want. In this case, we're using that comma because we've got our string in a state where, we've got our string in a state where we're just names split by commas. So commas are perfect. And then we're going to create a list. So now when we print at the end, we're going to have a list. And that list is going to be called data. Let's see what we got. Bang. And I know we're good. Why? Because look down here. And I'm sure with the magic of Camtasia, I'm zooming in. You can see the brackets. And then everything is in a single quote. So I now have a list of individual names. They're strings still, obviously. They're alphanumeric characters. But they're now in a list, so I can look at them name by name. Okay? Now, if we do a len, what is it going to tell us? It's not going to tell us how many characters we have anymore. It's going to tell us how many items we have in our list. And we can see there are 579 items in our list. Okay? So, you're probably saying, great, we now have a list. Who cares? You should care. And the reason you should care is this. We're going to go get more fun code now. Now that we have a list, we are in Fat City. And the reason we're in Fat City is now we can do things. Because a list is something you can iterate over. And the minute you can iterate over something, that means you can examine it. That means you can count it. That means you can accumulate it. That means you can do all of these different things. Because once you're in a list, you're in a data structure that we can start doing things with. And here, I have a little piece of code that's going to allow us to run through this list of names and look for the name Elva. And when it finds the name Elva, it's going to print Elva and then print what number in the list Elva is. Because I have a counter here. Now, this may be the first time you see this. I set my counter to 0, and then I say for I in data, because it's a list, which means it's an iterable, which means I can iterate over it. Then I click a counter. I'm not saying C equals C plus 1. There is a operator called plus equals, which does the same thing a counter does, only it doesn't make you put the C twice. So you can say C plus equals 1, and it's equivalent to, here, I'll actually write this in there because you're going to get this code. C plus equals 1 is equivalent to C equals C plus 1. Okay? It's the same thing. It's just a counter. And let me get that off to the side. Okay? And then I say if I, which is the item we look at every time we iterate through, equals to, because I'm interested in equivalence, not assignment, the string Elva, then print the string Elva and the counter, okay? And then when I jump out, I print C because that'll tell me the total. I think I know the total already. It's 579. All right, there we go. Look at that. So it ran through the list. It didn't print the list. All it printed was Elva, and I'll do it again so we can see. Oh, it did print the list. What am I doing? Oh, it's printing up here. Okay. Let me get rid of that. There we go. So now it prints the total, prints Elva. Elva is the 553rd name out of 579. So it should be right around here. Oh, my eyes are not that good. Oh, there's Elvira. I got fooled. I got skunked. This is a colossal waste of time. There's Eula. All right, forget about it. It's probably on the screen and you're all screaming. There it is. There it is. I can't see it. All right. Now we read our data from a file, put it in a string. We use data cleaning techniques, replace and split, to take that big old string and put it in a list. Put all the data in a list, so now that we have it in a list, we can count it and examine individual names and do a lot of things with it. Okay? So those are the kinds of things you're going to do with files and file I/O. All right? That's really it. You want to open the file, read it in, close the file, and then manipulate your data to get it into a form where you can actually use it and do things with it. As you know, I'm going to save all this, and you're going to be able to play around with it without having to code it all. But there's still two other things I want to do. I want to show you this. Oh, actually, there's two more things I want to do. I want to show you this construct because I would feel bad if I didn't, because a lot of Python programmers use this. I use this exclusively. What I just showed you, I don't use anymore. I use what you're seeing right here. Okay? And what it's basically called is it's called a Wif construct. And what it does is in Python it says with, and then you give it a tool or an iterable or something that you want to do. And you say as this thing, and then line by line you can go through the thing. So I say here with open, and I have a file called numbers.dat, and I'm going to show it to you. That's all numbers.dat is. All right. I think the one that you have in your resources has this is my number file or something on top. I got rid of that, and I just start with the numbers. Okay. So 12, 23, 34, blah, blah, blah. You'll see why that's important in a second. So I have a number file sitting in there. It's called numbers.dat. And I say with open numbers.dat R for reading as F. And then I jump right into a loop. For line. You don't have to use I or J or K. I call the variable line there. And I say for line in F, because I've already set up F as my file handle, I print the line. So I'm basically just printing it out. After this is done, the with construct automatically closes the file. It's almost like jumping off and running a function in local space. I'm going to really quick do something with that file line by line. It's really good for reading things in and other things. And then when I'm done, it does the close automatically. Okay? You don't have to worry about the close after that. Because a lot of people will open files and then do file processing and blah, blah, blah. And then go get more data processing, blah, blah, blah. Python programmers don't work that way. We open up the file, we grab all the data out of it, and then we close the damn thing and get rid of it. All right? With is a very useful thing. If you find it confusing or you don't want to do it, or you're like, as and in creep me out, I'm not really sure how they work, forget about it then and just do these up here. Okay? It's not important. Super important how you do it. Later on, when you get more comfortable with Python, you become a Python programmer. You're already Python programmers. You just don't know it yet. I will bet you $1 to a donut you're going to be using this. All right? Let's run it and see what hey, let's not highlight it. Let's run it and see what we get. All right. Yay. All right. Well, real complicated stuff here. 12, 23, 34. And if we go back to the original file and give it a look-see, we'll see that look at that, how that works right there. See? That's pretty much our file. All right? You're going to see that in a moment. So there's one last thing we need to cover. We've covered the simplest way we can open up a sequential file. When I say sequential, I mean we're reading a character-based file, character by character. When you get more complicated, you're going to see that you can read in files by objects. You'll know what they are in Unit 5. You can read in files with binary. At the very end of this video, I will discuss pickling, but we're not doing anything with pickling. So feel free to forget pickling. It will not be on a quiz, and it will not appear in your assignments. But like this construct right here, I want you to be aware of it, because in my mind, a big thing in education is community of practice. you are taking this class in order to become a Python programmer. Well, Python programmers know about with as, and Python programmers know about pickling. So I want to give you exposure to this stuff, even if we're not going to use it. And even if I'm not going to grill you with some stupid quiz question, I want you to be aware of it. And I want you, when another Python programmer says something about pickling or marshalling, you're going to know what they're talking about because you had this little section. That's my goal. I'm not looking to kill you. I'm just looking to let you in on, the jargon and the secret sauce when it comes to being a Python programmer. You'll be all right. Don't worry about it. So, you know about with as, you know about regular opening, reading, and closing. So the last thing I'm going to do is we are going to write, because that's really the second thing we want to do when we deal with, do I have one on the bottom? Yeah. When we deal, and I've got that zoxed off, and I have that zoxed off for a reason right now. I want you to see output files too, because a lot of times that is the sequence. You will read in data, and then you will manipulate that data so you have it in a form you like, and then you will save it to a brand new file. And then that brand new file may be used as input for another process and go down the line that way. So I want you to see output files as well. Very simply, with the code you see in front of you, I'm creating an output file. I have the variable OF. I'm making it equal to open, and then I give it a name. This file does not exist yet. Okay? You can see right there, there's nothing called outnums right there. All right? I made it up out of whole cloth, and I'm giving it a W for writing. So when Python encounters this line, it's going to tell the operating system, hey, go create me a blank file called outnums.dat. I'm going to be putting stuff in it. And the operating system will listen to Python. And the beginning of that file, where it will start writing, is what the variable OF is pointing to right now. Okay? Then, I guess because of habit, I did a Wif construct, and I said, okay, with my numbers.dat file, which we've seen before, 1223, all of that, as F, I want to, line by line, for line in F, and I don't print it. Actually, you know what? I am going to print it when I go through with you. The first thing I do in my little line-by-line loop with numbers is I print an integer of the line. I then create a variable called bump, and bump equals the line I read. Remember, when you're reading out of a sequential file, you're reading strings. So when I read in that first line, it's 12, but it's really 1, 2, \n. Okay? So I've got to cast it to an integer, because the integer will take the string 1, 2, \n and make it a 12, make it an integer. So I want bump to equal 12 plus 1 and make it 13, and then, and this is the line we want to see, I want to write it. I say OF dot, I'm going to run a method on the variable. I'm going to say write, and then I'm writing to a file, remember. So I want to take bump, which is an integer, and I want to make a string out of it. And then I'm going to concatenate. Remember, when we deal with strings, the plus is a concatenation. You're putting two strings together. And I'm going to add my \n. So when I write to the file, I'm going to write a 1, and then a 3, because bump is 12 plus 1, and then I'm going to write a \n. So then the next thing I write will be right next to it in the file, but when I print it out, it'll give me a new line. You'll see how this works. Now, there's a little trick here, and we're going to run it once and go through this little trick, because it's important, and I want you to see it if I don't do it. So I go S, I run things, hey, my file prints out. Fantastic, because I told it to print out. So now I should have a file called outnums.dat. Let's go look. All right, oh, look at that. It's there. How wonderful, but I think we might have a problem. Dun, dun, dun! I double-click to go look at it, and it's blank. Oh, my Christmas, what is going on? Why is Python not working? What's happening? The issue is this. We did not close our output file. If you don't close the output file, it's not going to write everything to the file. This is why. A little behind the scenes. I'm not writing to that file when I do of.write. I'm writing to a little section of memory that's been put aside to be my file. Okay? That's how programming languages work. I've got a little hunk of the heap or RAM where I'm putting what's going to be in my file. I write my file when I close it, okay? Because there's no other reason to write it until you do the close operation. When you forget to close an input file, sometimes things are okay because I've already read in the data. I'm not going to change an input file. It'll load up my memory, but these days we're lousy with memory. So, you know, back in the dinosaur days when there wasn't a lot of memory, you remembered to close your files. Otherwise, there would be a memory location taken up with a file pointer. And you'd know, after a while, opening a lot of files, you'd notice that. But now, we have more memory than we know what to do with, so sometimes it's not that big a deal leaving input files open. But, and this is why I always close them, because it's good to be, I always call it being a good file citizen, always close your output files, or you're not going to write the thing, and it's useless to do it. Now, I've got religion, of.close, I'm going to run it again. Same thing right there, but now I'm going to go up here, and I'm going to see outnums 1K, and look at that, okay? Now, if I'm not mistaken, you can see it's my my numbers.dat, but everything is increased by 1. And why is that? Because that's what we did in the code. See? Look at that, all together. That's what we did. We did a bump, and then we wrote it. So the 12 became a 13, the 23 became a 24, the 34, 35, and on down the line. And then, after it was all written to a side file, we did the close, and it wrote the file. Okay? That's what we're talking about. Now we're starting to get somewhere. We read in numbers from an input file. We did some processing on it. Not exactly the most complicated bit of processing in the world, but we took individual lines and added 1 to it, and then we wrote it back out to a brand new file. Outnums.dat didn't exist 5 minutes ago. We created it, and now we have it on our hard drive, and we can use it tomorrow. Tomorrow I'm going to come back, and I'm going to run it, and I'm going to make it a 14 and a 25 and a 36, and there's no end to what we can do. How boring. All right. Hold the phone. I think there's one more thing I want to do. What's the one more thing I want to do? I don't think it has anything to do with code. Can I do a grand finale with this stuff? Or is it just going to break and be goofy? There's only one way to find out. Hey, it worked. Okay. So there's your grand finale. Kind of boring, but I bet you it created a new outnums, did it? Yes, outnums is fine. All right, good to go. All right, so as I always say, I'm taking this file and I'm putting it in our resource folder so we have it. Now, that way you'll be able to look at all the file stuff. You can watch, this is YouTube, watch this video as many times as you want, and you can stop it and go try something out and then come back and start it right up. So that's why these YouTube videos are good. Can't do that with a regular lecture. Stop and then go try something for like 5 minutes and then just say, start. That would be great, wouldn't it? One last thing I'm going to do with you. And I think I have it set up somewhere. Is we'll talk about pickling. I'm not, you know what? We're going to talk for less than a minute, hopefully. Because this is just something I wanted you to see. In Unit 5, we're going to talk about objects. Objects are like lists, but they're lists of different kinds of data and what you can do with your data. And they're basically little simulations of objects. So back in the day, they weren't easy to save, okay? Because it's easy to save a string. It's just a sequential file, boom, boom, boom. An integer is easy to save. You're just saving numbers, boom, boom. Floating point isn't hard to save either. I'm going to do boom, 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 dot, boom, boom, boom. Objects are more difficult to save because you have to know the data type as well as what you're saving. And for lack of a better way to put it now, because you'll learn about it later. An object is kind of like a custom data type. So you don't know what it's going to be ahead of time. And what pickling is Python's way of doing a process called serialization. And if you think about what the word serial is, it just means putting things in a straight line. You know, a serial circuit versus parallel. Serial is just in a straight line. It's serial that way. And basically all you're doing is you're taking an object and you're extracting all the data out of it, and you're saving it in a sequential file. You're basically taking something that's complex and maybe not all in a row, and you're making it serial. And then once it's in that form, you can save it to a regular sequential file. And that's what people used to do. It's called, whenever you see serialization, that's what people are talking about. Taking things out of a complex data structure, making it easy and in a straight line, then saving that to a file. Then when you read your object back in, you'll get that straight line and you'll rebuild your object or your data. Now, back in the 70s and 80s, they used to call it marshaling your data and controlling it that way. But all of a sudden, that term went out of favor. And in the 80s and the 90s, when C++ came around, they started calling it serialization. And then all of a sudden, and I don't know why, in the 90s, big data people and data storage people started calling it marshaling again. So you might hear that term. That's why I'm letting you know I'm using both. There's marshaling and there's serialization. It's not hard. It's taking something complex and making it a straight line so you can save it to a file, just like we did 2 seconds ago with our other file stuff. It's not hard, okay? Now, that said, don't worry about it. I just want you to see it. I just want you to know the terminology. I just want you to have a little bit of exposure to the idea, because it's not going to be on any quiz. You're not going to do any pickling in any assignments that you do, okay? Don't waste your time on it, okay? Read the slides, understand it. If someone asks you about pickling, you know what they're talking about. If someone asks you about serialization, you can say, well, I have a small idea what it is. Now you can go Google it and get hardcore if you'd like. If you want, you can look at the pickle library, where it comes from. That's another thing. Pickling happens to be the last thing I talk about in the file section, and it leads nicely into importing libraries, because you have to import the pickle library. And importing libraries is what we're going to get into in our next video, because this one is over. All right? Don't let pickling make you crazy. All right? You can go play around with the code and you can go do other things, but if you don't do anything with pickling, you are going to be fine. You have no worries. All right? Well, half hour, that's not so bad. Where's my code? I'm going to put this code up on the resources for Python for Unit 3, so you're going to be in good shape and you are going to be fine. Announcements. You're probably not going to get this video until over the weekend, but I am recording it Thursday night. So my Thursday night brain is telling me that I'm going to be able to get you all of the resources for this unit pretty easily a week before everything is due, so don't worry. Over the weekend, you will get the assignments. Actually, I'm probably going to give you the first one on Saturday and then the second one on Monday. When you get the second one, do not freak out. You wait until you get the third video. And then after you watch the third video, you're going to go, oh, okay, and you will get it, all right? Do not freak out when you see the second assignment. I will get you the assignments over the weekend. Over the weekend, I think Hans, who's been really good with grading the assignments, is done already. And it's just my lazy butt having to sit down and grade all of the quizzes, which shouldn't take me that long, but I'm been very busy recently, so I need to get going and get that done for you. And then hopefully early next week, I'll be sending out the emails with your Unit 2 grades. From what I've seen, you all did very, very well. All right. Another announcement on Monday. I don't know when you're seeing this video, but on Monday, the 27th at 4:30, we're meeting in person. We will go over some simple announcements, and then we'll be doing some live coding. Hopefully, we'll be doing some live coding with functions, and we'll be doing stuff with file I/O and cleaning up files. And we might, be running through some things that might be helpful as far as the assignment is concerned. So if you can be there, it's a very, very good idea to be there. I believe that is it. I'm not going to be a broken record. Well, that's not true. I am going to be a broken record. Please, 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 please engage with the resources early. I'm preaching to the choir, though, because if you're watching this second video, I'm guessing you're caught up. You've read the books, the Zell, you've read the slides. I want you to read the Zell. I think it's good to get things from a couple different sources to learn properly. That said, the slides are more important. Do the slides and watch these videos. But I want you to have the Zell, because Zell is good coverage. Zell is a good way to see it a third time. It's that last coat of paint, and it's the book you'll have with you when you leave, and that's why I give it to you. It's good coverage. It's got graphics, it's got objects, it's got simulations, it's got lots of stuff. I don't like the fact that he does functions before loops. I think that's just bananas. But I don't know. It's a total love-hate thing with me with that book. But I just think it's a good thing for you to have. All right? So you're going to be fine. Unit 3 is going to be good. I want you to engage with the resources, though, early. Because when you get that second assignment, and you're going to see you have to read from a file of 10,000 random numbers. You have to clean up that data, and then you have to examine that data with the function that you wrote for assignment 1, and then you have to do another function that runs on it, and then you have to do another thing, and then you have to give me results from that thing. And when you first read it, you're going to go, oh my God, he's crazy. I can't believe it. But after a while, you're going to go, oh, you know what, it's not so bad. And then when you see the third video, you're going to go, oh, I can do this. I can definitely do this. But you've got to read the slides. You've got to read the resources, and you've got to get it. All right? You're going to be fine. This class is going well. I'll be honest. I didn't tell you at the time, but I was scared to death. I thought, we're going too fast. There's no time to breathe. There's no anything, blah, blah, blah. But you guys are doing a good job. You procrastinate too much. But you know what? How can I complain? You're doing well. You're doing the assignments well. Now, it might be because you're going on YouTube and finding my old videos, but that's a good thing too. We're going to talk about that on Monday. That's a little trick, because I want you to go find those videos, and I want you to look at those videos. But you're going to find out from Unit 3 forward, you're not going to get anything about the assignments anymore. You're not going to get anything about the quizzes anymore either. So you better start engaging with the resources, because as far as finding nifty little videos that talk about quizzes and talk about assignments, you don't get them after Unit 2. All right? So make sure you engage with the resources. The jig is up, but we'll talk about that little trick on Monday. All right? And I'm getting out of here. All right? It's 20 after 10. It's not so bad. I might do another video tonight. You never know. I'm video crazy. All right. I'll talk to you later. You be good, and have a good night. Bye.